So we've seen in other videos how to create a vector plot using the VectorPlot dialog. And this allows you to add one vector at a time to a plot until you're done. And then you hit done and you get your vector plot. And that works well, except for that it's difficult using that technique to modify the vectors that are plotted and how they are plotted. And so the $VectorPlot directive gives you a powerful way to get around this limitation. And this is a directive that's available if you are using a professional license of ease, either the professional license or the academic professional license. And this allows you to quickly and programmatically generate a vector plot based on the results of your ease program. So this is the format of the $VectorPlot directive. You can see here that what you have is, first of all, a specification of the name. So name equals, and then you have a string, which is what the plot will be called. And then you have a list of vectors that you want to plot, right? Starting with vector 1 here. So this is a vector variable in ease. And then after the colon, you specify what its origin wants to be. And then you can also specify the color. And if you want, you can continue on plotting vectors in this manner. The origin specification here takes a little bit of thinking about. So if you want the vector to just start at the Cartesian coordinate system origin, so 0, 0, 0, then that's easy. You just put a 0 there, and that's where it'll start. If you want the vector to start at a location that's specified by another vector, then you would just put the name of that other vector there. And then finally, there's a lot of times you want the vector to start at the head of the previously plotted vector. So if you want that to happen, then you would put an exclamation point. And with this $VectorPlot in place, every time you run your ease program, it will then automatically regenerate this plot. So you can look at it kind of in real time as you're changing the parameters. You can see how the vectors are changing, which is really nice in some problems in order to visualize what's going on. So let's just do a real simple example here. So I'm going to create a code here that has 3 vectors, A, B, and C. And the first 2 I'm just going to assign. So A is going to be -1, 2, -1. And B will be maybe 1 and then 0.5, 0.5. So these are 2 vectors that aren't parallel to each other. So it'll be interesting then to set C to be equal to the cross product of A and B. So I'll use the vector cross function for that. And then down here, I'm just going to plot these vectors. So $VectorPlot, I'll call the name of my plot ABC. And I'm going to plot A starting at the origin and make it black. And B also starting at the origin, and it will also be black. And then C will also start at the origin, but I'm going to make it red. And if I solve now, you can see that I have all these 3 vectors shown, and A and B are shown, and then C is perpendicular to A and B. If I made the axis extents equal, it would be clear that they were perpendicular. If I change A or B, so if I go back up here and change A to be, I don't know, -2, 2 -1 or something like that, and solve again, you can see that my plot instantly adjusts to this new solution, which is really nice. If I wanted to, I could plot these 3 vectors head to tail. I'm not sure why I'd want to do that, but maybe I do. So I can, underneath the first $VectorPlot, have a second one, $VectorPlot. I'll name this plot something different, so maybe ABC2. And the first vector, of course, has to have a specified origin because there is no head of a previously plotted vector to use. So I'll start it at the origin, make it black. And then B, I'm going to start it at the head of A. So that's what the exclamation point is used for here. And then C, I'll start it at the head of B. And that's what the exclamation point is used for there. And you can see then that I get this sort of head to tail plot, which is, again, often handy in statics or dynamics problems when you want to see how the forces sort of sum together to create a resultant. If you have 2D plots, or 2D vectors instead of 3D vectors, You do basically the same thing. It's just that you use $VectorPlot 2D instead of $VectorPlot, but otherwise it's the same. The images are, two-dimensional plots instead of three-dimensional plots, but the protocol is exactly the same.